In this video, we are going to calculate empirical formulas for compounds using either masses that we're given or the percentages of each element that we are given. And so in this example, we are asked to find the empirical formula of a molecule that contains 65.5% carbon, 5.5% hydrogen, and 29% oxygen. All right. So how can we calculate the empirical formula for something if we're given the percentages? Well, if you add up all the percentages, you should get 100. And we're just going to substitute that percent symbol for the G for grams. Okay. And from there, we can do all of our calculations. So 65.5% carbon becomes 65.5 grams of carbon. 5.5% hydrogen becomes 5.5 grams. And then we have 29 grams of oxygen. Okay. Now, in order to find the empirical formula, we have to determine moles of our substance. Okay. And so how do we go from the masses that we're given to moles of the substance? We're going to divide by molar mass. So we're going to divide the 65.5 grams of carbon by the molar mass. And we get the molar mass from the periodic table. The periodic table you're using may have a slightly different value for the molar mass, but that should be okay. It should not, like drastically change anything. Okay. And so here are our molar masses of these substances respectively. This is carbon, hydrogen, and then now we have oxygen. Okay. And so when we divide by our molar masses, we get our moles, and our answers are 5.45 moles of carbon, 5.46 moles of hydrogen, and 1.81 moles of oxygen. Now that we have our moles, okay, what we do is we look for our smallest value, okay? And we are going to divide our moles that we just calculated. We're going to divide all of them by the smallest one. And so 1.81 is the smallest value. So I'm going to divide that by itself. Okay, I'm going to do the same thing for the other two. Uh-oh, I got to put my decimal. Okay, going to divide everything by 1.81, and that is a decimal that is lodged right after the 1, and we're going to get our moles. All right, so we've taken this and we've divided all of our moles by the smallest value, and that will give us the subscript for our empirical formula. Okay, we have whole numbers, and that's what we use. So if we look at it, our three elements are carbon, we have hydrogen, and we have oxygen. And so we have 3, 3, and 1. So it's C3H3, and we don't write the 1. So C3H3O. So that's how we do empirical formula. And if I would give you a set of steps, a set of directions that you would basically do whenever you're finding empirical formulas, this would be it. Step 1. Step 1, you are going to convert your masses. So you're going to convert all the masses of your elements to moles. Okay, and so like I said, we should all know how to do that. We go from mass to moles by dividing by the molar mass on the periodic table. Step 2, divide all of your moles, your calculated moles, by the smallest value. So in the example that I just went through, when I found all of my moles, the smallest value was 1.81. So everything was divided by 1.81. Okay. Step 3, if the answer, if the answer after step 2 is a whole number, um, then these are going to be your subscripts. Okay. Now you might be going like, well, how do I know it's a whole number? Because a lot of these things that we get when we do stuff in class, they're not whole numbers. All right, let's say you had 3.0178. That basically equals 3. Okay, that's a whole number. If you had 2.987, that rounds up to 3. Okay. Now, if I'm doing this, that means that there's a possibility that you may not have a whole number. And so if you had 1.5, okay, then you will not round that up to 2, but you will multiply this 1.5 by a number that will turn it into a whole number. So 1.5 times 2 equals 3. And what you do to this, you will have to do to all of the other numbers that you calculate. Now we're going to do some more of these practice problems, but I just wanted to quickly show you how to find empirical formulas from either masses or percentages. All right.